Okay, we're going to group 3.1 and 3.2 together. So we're going to investigate and verify properties of triangles. So we already did a little bit of a warm-up investigation. And from that investigation, we recalled slope and length of a line. So the distance and that, okay? If you actually take a look at the slope and the length of a line, y2 minus y1, we can see that right here. So these actually are the same numbers, and x2 minus x1 is the denominator of the slope. Okay, but instead of divided, these ones are squared and added. So don't think that they're the same, but the numbers should look quite similar. Okay, so let's just go through this this chart. So there's different classifications for triangles. So a right triangle, we think of two sides that meet at 90 degrees. Okay, and we kind of already did this. Pythagorean theorem holds for a right triangle. So AC meets BC right here at 90 degrees. So this is a right triangle. Now, equilateral triangle, we know that all sides are equal. So all three sides are equal in length. Okay, so all three sides, 1, 2, 3, all the same length. Okay, so we'd be looking for a distance formula. Okay, I just want to note all three angles are equal as well. They're all 60-degree angles, but for the scope of this lesson, we're not going to focus on angles yet. Okay, let's scroll. All right, isosceles. So when I think of the word isosceles, I think of eyes. Okay, how many eyes do you have? 2. Therefore, 2 of the sides have the same length. So this side and this side will have the same length. In turn, this angle and draw an arrow, this angle will also be identical. Okay, so when we're thinking length, again, I think of distance formula. Okay, back up here to right, when I think of 90 degrees, I think of slopes, and I think of negative reciprocals. Okay, now scaling. All sides have different lengths. So 1, 2, 3 dashes. Okay, so all of them have different lengths. Again, I'm looking at D, distance formula. Okay, example 1. The vertices of a triangle are A, B, and C. Verify that this is a right triangle. Okay, and then we can include a sketch. So we did a question similar to this. So let's go negative 2, 2. That's going to be A. B is 6, negative 2. And 4, 4. Okay, if we sketch this initially, which two sides meet at 90 degrees, or which two sides look like they meet at 90 degrees? I would definitely say AC and BC. So angle C looks like it's 90 degrees. Let's solve this algebraically. So method 1, we're going to actually use slopes. So please note, a right triangle has a 90-degree angle. The two lines that form that 90-degree angle are perpendicular. We know that perpendicular lines have slopes that are negative reciprocals. So without actually drawing this and assuming that angle C is the right angle, I would find the slope of all three, AB, BC, and then AC. Okay, difference in the x's, or difference in the y's, negative 2 minus 2, over 6 minus negative 2. So negative 4 over 8. I'll put it beside, bad math form, negative 1/2. Now, the slope of BC. So 4 minus negative 2. We have 4 minus 6. So that gives us 6 over negative 2, which gives us negative 3. And now let's find the slope of AC. So 4 minus 2 and 4 minus negative 2. 4 minus 2, 4 minus negative 2. Okay, lots of just repetition math here. 2 over 6, I get 1/3. So if we compare these right here, we can conclude, so therefore, say triangle ABC is right. Okay, now let's do the same thing, but let's do it using Pythagorean theorem. Okay, so to use Pythagorean theorem, what we need to do is we need to find the distance of all three sides. And then we'll sub it into Pythagorean theorem and ensure that Pythagorean theorem holds. Okay, so let's find the side of AB. So subtract the x's. Let's go 6 minus negative 2. Square it plus negative 2 minus 2. Subtract the y's. Okay, I get 8 squared plus negative 4 squared. So I get 64 plus 16, which is root 100. Okay, now let's go distance of BC. Because remember, I always assume that we can't draw it and assume which angle is right. So I always just calculate everything. So distance of BC. So difference in the x's, 4 minus 6. Square that, and then add 4 minus negative 2. Square that. So I get negative 2 squared plus 6 squared, which I get 4 plus 36, which I get root 40 units. Okay, and now D, AB, BC, and AC. I was just thinking, because we're using Pythagorean theorem, we actually need all three sides anyways, or it's not going to work. Okay, difference in the x's, 4 minus negative 2, and then 4 minus 2. Let's go 4 minus negative 2, square that, and then 4 minus 2. Okay, it should be a pro after all of the practicing that we have with these questions. Okay, so again, I get root 40. And it doesn't look right. I actually miscalculated this. 64 plus 16 is 80. My mistake. Okay, so we have three sides. We have AB should be root 80. And then this should be root 40, and this should be root 40 as well. So what we want to do is we want to take these three side lengths, and this should be units, and we want to sub it into Pythagorean's theorem. Okay, so when we have a root and a squared on the same number, what happens is they simply cancel out. Okay, and we know that from doing Pythagorean's theorem since grade 8. So we would have the number root 40, and we would square it, because that's what's in the formula, plus root 40, which is our number, squared, equals root 80 squared. So this squared and this root go away. This squared and this root go away. This squared and this root go away. We get 40 plus 40. Our question is, does that equal 80? Yes, 80 indeed equals 80. Therefore, this angle, this triangle, let's call it ABC, is right. Okay, because the Pythagorean theorem holds. If the Pythagorean theorem doesn't hold, we would get something like, I don't know, 54 equals 80. Well, we know 54 doesn't equal 80, so then, therefore, we could conclude that the triangle is not a right triangle. Example 2. The vertices of a triangle are A, B, and C. Okay, if M is the midpoint of AB, N is the midpoint of AC, let's verify that MN is parallel to BC, and then MN is half the length of BC. Okay, so let's first plot this. A is 2, 5. Sorry, negative 2, 5. And then we have 4, 1 is B, and 0, negative 5 is C. Okay, so let's join those. Now it looks like a triangle. Okay, so first of all, M is the midpoint of AB. So I can look at this and I can guess that it's 1, 3, but let's actually solve for this. So capital 1 of AB, negative 2 plus 4 divided by 2, comma, 5 plus 1 divided by 2. Negative 2 plus 4 is 2 over 2. I get 1. And that's 6 over 2. I get 3. So it is 1 comma 3. So let's call that M of A, B. 1 comma 3. We have to verify that, so M is the midpoint of AB, N is the midpoint of AC. So the midpoint of AC looks like negative 1 comma 0. But let's actually check it. Oh, and it's not N. It's going to be, let's call that M. Okay, so the midpoint of AC, and then in the next line, we'll call it N. Okay, midpoint of AC, negative 2 plus 0 divided by 2, comma, 5 plus negative 5 divided by 2. I get negative 1 comma 0. Negative 1, yep, negative 1 comma 0. So first we want to verify that MN is parallel to BC. So MN would connect like this. How we would prove that that's parallel is we would be finding the slope of MN and then the slope of BC. And we're just making sure that they're the same. Okay, parallel slopes are the same. So we get 3 minus 0, 1 minus, other way, n minus n. 0 minus 3, negative 1 minus 1. So I get negative 3 over negative 2. I get 3 over 2. Okay, BC. So let's do negative 5 minus 1 over 0 minus 4. I get negative 6 over negative 4, which simplifies to 3 over 2. Those are the same. Therefore, MN is parallel to BC. Let me put little arrows on that to show. Now I'm going to change the color. Let's verify that MN is half the length of BC. So all we have to do is find the distance of MN. Okay, difference in the x's, negative 1 minus 1. Square that. 0 minus 3. Okay, negative 2 all squared plus negative 3 squared. I get 4 plus 9. All rooted. So I get root 13. Now let's try to fit in the distance of BC. BC. So we're going to do 0 minus 4 and negative 5 minus 1. 0 minus 4, square that. Negative 5 minus 1, square that. Let's move underneath this. I get 4 squared plus negative 6 squared. 4 squared is 16. 6 squared is 36. 3, 4. I get root 50. Let me check. All right, that looks good. So right here, we can't actually really, we can't tell if this and like the root 13 and root 50 are halved. So let's actually root the 13. I get 3.6 units. Okay, and if we root the 50, we get 7 units. 7.1 units. Remember that those are rounded. So I'm very, very comfortable saying, therefore, MN is half the length of BC.